Okay. So this is Alfonso Berumen again from Pepperdine University, Decision Sciences. And in the first part of this tutorial, we walked through a factor analysis using the UTAUT data. So if you are at this point or in part two, you won't be able to make any sense of what goes on here. So I definitely would advise you watch part one. So I didn't delete any of the objects or remove any of the data I had from the first part. So I'm just continuing on with my program and my script. So again, we started with exploratory factor analysis, and we actually decided on, okay, well, 6 factors is justifiable and appropriate. So now we've actually have some evidence or provide some evidence to suggest that we have 6 different factors. In fact, we're going to now look at the reliability within those factors. So you can kind of see here, if I look at the reliability block, um, I'm actually going to start with just selecting, facilitating conditions just as a example. So I'm going to select those 3 items. And then I'm also going to just look at a box plot, and I'll go ahead and run that. And you'll actually see here, if I look at my box plot, you can see that, Likert scale, um, it's not a continuous variable, right? But it does give me a sense of, where most of the responses lie and how they kind of spread out for each of these questions. You can see here for FC3, the median was 5, 25th percentile was 4, 75th was 6. And then for FC2, 6. For the median, 25th was 4. And yes, in this case, the median is 5. This case, median is 6. The 75th is 7. And then you have 6 as the median, 25th is 5, and then 75th is 7. So you can kind of see the how those values are spread out. I'm looking at the reliability first. There's actually 2 measures that we'll look at. So I'll actually look at both the Cronbach's alpha as well as the omega. And actually, there's a third measure we'll look at is the composite reliability. They are a little bit different, and I'll kind of talk about why those are different and why they kind of exist. And the alpha is really the quick reliability check. Omega, that's allowing for the items to have unequal loadings, right? So slightly different procedure there, right? So you would actually need loadings to be able to do that. And then the if we're using kind of CFA SEM, we want to use Cronbach's. Sorry, we want to use composite reliability and omega. If we're just reporting the psychometrics, we would look at alpha or the Cronbach's alpha and omega. So just to correct myself again, for the CFA SEM setting, we would use our composite reliability and omega. Um, for Cronbach's alpha, the cutoff is 0 0.7, right? So greater than equal to 0 0.7. That would measure your internal consistency. That's where the loadings are equal for each item. McDonald's omega, we allow for different item loadings. So we need the factor loadings, from EFA or CFA. Same cutoff, and then same thing with composite reliability, similar cutoff of 0 0.7, and that requires CFA. So that sort of matches the SEM assumptions. All right. So we have alpha here just to kind of start out. And you can see with the the quantum box alpha, you see the value of zero point 0.6, right? So zero point 0.6. And you also see if you dropped a certain item, how the alpha would change, right? So if you drop an item, how the alpha would change. And you can kind of see there FC1 is, there does seem to be a little bit problematic, and it would actually get us above that threshold, right? Um, so we may decide, or you may justify dropping that. And in fact, if you look at the actual question itself, it is a little bit convoluted, right? I have the resources and the knowledge and the ability to make use of the computer. Um, and then if you look at the other ones, right, such support was available. Management provided most of the necessary help and resources for computing. That is a little bit different, right? If you look at that, maybe the effort expectancy construct, it's easy for me to become skillful using computers. I find computers easy to use, computers easy to use. If you read this wording content-wise, I don't know, I may even perceive that as falling under effort expectancy, right? So it's a little bit confusing in that sense. And it doesn't really align as well. And not a knock on this published research, but it does kind of provide a red flag, at least from my personal opinion, that matches with the math as well. So looked at Cronbach's alpha. We're actually now going to look at omega, and we do get an error. So let's print those results. We do get an error message because we're running it with kind of one factor. So don't worry too much about that. But if you look at this sort of one factor model, you do see the omega total. So scroll a little bit up again. So you see the omega total 0.64. You actually see our alpha here 0.58. So that's your quantum box alpha for comparison purposes. There's a hierarchical as well. That doesn't apply here. It's actually meant for bifactor models. We forced a one factor solution onto three items, or the three FC items. And so we're going to ignore that, right? It's not interpretable. We'll look at the total. So 0.64, a little bit better than the alpha, still doesn't meet that 0.7 threshold. And so we'll keep going here. I don't interpret the hierarchical. So the FC construct may need some work, right? That's going to be my takeaway from this. And then finally, if you look at the factory loadings, it actually is pretty low, right? 0.24, pretty low. That would suggest that there's a weak general loading here. And also there's a low commonality, right? 0.06. So that's the other thing we may look at. So the FC1, you have a strong argument now at this point to potentially drop FC1. Obviously, theory is going to often sort of trump that, right, or could trump that. But let's go ahead and look at the full omega, and I'm actually going to go through all of this code, right? So we're actually saying six factors. Let's look at the full omega, and then also look at and this is just a kind of prettier way of outputting this. Let's highlight here. So if you highlight all of this, some mouse issues. So let's highlight all of this. I'll go ahead and run that. So it gives me a nice table at the end. You could do this by looking at the output kind of more manually. But you can kind of see if I look at The top here I have the omega results, right? So the omega results at the top. We just summarized it and kind of put everything together at the end. But you would kind of just modify this and create your sort of list of items for labeling purposes, then create like a nice clean table based on these functions in a similar fashion. So if I look at my alpha, right? So that only looking at the total hierarchical doesn't apply here because I forced a one factor model for each of these now constructs, and then you can see the items that are in there as well. So you see the alpha, uh, so pretty good here, greater than 0.7 for PE, good here for EE, good here for subjective norm as well. And then the facilitating conditions we're a little bit more concerned about, right? So I had that as an example earlier. 0.6, 0.64, that's some marginal reliability. So one or more of those items may be weak, and we know which one that is. Um, and then the behavioral intention, pretty poor reliability, so we could use some revision there as well. And then we're good with the use, right? Usage behavior, we're good there. So, one of the things we could kind of take away from all this is that with respect to reliability, facility conditions and behavioral intention to use, um, there could be some questions there, right? So behavioral intention might actually benefit from some revision or maybe even some rewarding as well. We might take a look at those survey items similar to what we did with the facilitating conditions as well. So what we'll then go ahead and move toward is CFA. And again, often the basis of this is, hey, there's a justified theoretical foundation. So the authors obviously went forward with this data in this model and those constructs. But let's go ahead and kind of end this part and then move forward to part or part five of the so it's part three of the tutorial, but kind of part five in my coding block.